somewhat, but like, what are some of the main challenges of trying to localize the production of these technologies in big countries like America or in places in Europe or Australia and New Zealand?
I would say multiple. For example, in America, it probably takes 3 to 4 years to get permits to open up a mine. And there's the investment, you probably need at least $1 billion to open up a gigafactory. And the third part is you've got to train a workforce. Invariably, you're going to bring people over from Asia to actually train an American or a European workforce. So in the United States, I think Samsung is here, LG is here, SK is here. So the Asian companies are building it up in the United States, and they will eventually use call a North American, maybe a whole America supply chain eventually. If there are legal consequences and patents and things, then different companies have patents in their home country, but then they have conflicts in the US and can't necessarily import the materials they want. No, there's at least, I think, 4 or 5 gigafactories being built right now in the US. But all but one of them is owned and operated by Asian companies, and that includes Tesla's, which is operated by Panasonic. And I think it's the same situation in Europe. There's at least 2 large companies there, European-based, that are beginning manufacturing, one in Sweden, for sure. But I think it's the same issue as semiconductors. It's the same issue with things like vaccine and masks for COVID. You can't have everything in one country because when you crush, obviously any home country supplies their own people first.
I have one question regarding the grid storage application. So right now I'm completely agree, like lithium-ion battery is completely dominating this energy storage thing. But what's your thought about like other way of energy storage are coming, like this redox flow battery, liquid metal batteries? So will they going to compete with lithium-ion battery in future or somewhere?
I don't think they'll compete for 5 or 10 years. The real issue is lithium-ion batteries are built by the billions. There's mass production, they're the lowest cost. Because any other system to get down to that cost, they've got to find an expensive niche market so you can try them out. I think the biggest changes you're going to see is in the lithium-ion, the cobalt's going to go, probably the nickel's going to go, and they're probably going to go much more to lithium-ion phosphate where they were maybe 10 years ago. So they're going to swing back to lithium-ion phosphate, the grid, just as they're starting to swing back for electric vehicles, for lower cost electric vehicles going to lithium-ion phosphate. So you find more variations, I think, within the lithium-ion activity. We're the large government project, consortium funded, to actually make lithium batteries, so we start with pure lithium metal, so we can get them against the oxide. And obviously the other big area of interest is solid-state batteries. So you can use solid-state batteries and go to lithium metal. If you use the right solid-state electrolyte, it should not be flammable, but it should also be much safer. So there's lots of challenges there. So I think you're going to see a lot more variations of lithium, and maybe sodium will come into play a little bit. But I think we'll see lots of variations in lithium. The grid storage, the utilities want them to last 20 years. Any flow battery has moving parts, needs maintenance, it needs a professional to look after it, whereas lithium-ion batteries, they can look after it by monitoring a computer maybe 100 miles away.
Okay, I can add one more thing here. Like these liquid metal batteries. Can I add?
Yeah.
Okay. So,
Go ahead.
so liquid metal batteries are also coming, which have not very good energy density, but they have very long cycling life. They can go for number of cycles, and they have actually what they are claiming is that the cost is somewhere lower than even the lithium-ion battery, the kilowatt per hour. It comes under below 100 kilowatt per hour, $100 per kilowatt. So will it, like for grid storage application, you will not look at too much toward the energy density. I feel that the energy density concept will come more when you go for the vehicles, electric vehicles or something. So that's why I'm really want to know whether these liquid metal batteries can go for the application of grid storage.
So I think people have been looking at them for a while, I think particularly out of MIT. They tend to be high temperature.
ยังไม่ใส่หูฟัง
They
เลยได้
tend to
ดัง
be
ขึ้น
very corrosive. They've got expensive cell components. And I don't think there's anybody who's really tested them outside of the companies actually doing the research. They don't necessarily believe any data you see in literature, so a third party confirmed it. And the issue on energy density, it doesn't matter if you've got lots of space, but if you're putting storage, say, in a large city, whether it's a large Indian city or New York City or San Francisco, land is very expensive. And a lot of the storage they'd like to have inside buildings, in which case weight is a big issue, and safety is an even bigger issue. Because certainly in New York City, you cannot have the battery higher than where a fire truck can actually get to it. So not above about the 4th or 5th floor. And I should have mentioned there's another advantage of solid-state batteries. They can operate at elevated temperatures or room temperature, so you don't need to put air conditioning on them. All the grid storage today go from 90% energy efficiency to 70% because 20% has to be used to keep the batteries at what we call room temperature. So most lithium-ion only works at the same temperature that any of us are happy at. So that's between, I would say, 15 and 30 degrees centigrade. So if they could go, double that temperature, you could cut out the temperature monitoring. But we have to look at all the other options for storing energy. So you may get a breakthrough, and even if you don't get a breakthrough, it may make the present system better. You've got to have competition. Yes.
And I heard you mention about lithium iron phosphate and also the solid state. Would it be the potential future of the phone battery as well? Like can it be used in the phone as well, or only in the electric vehicle?
I think right now the phone batteries are mostly cobalt. But what's really critical there is how much energy you can store in a given volume. The lithium-ion phosphate is only about half that of lithium cobalt oxide. So I think there's a big push now to make some of the higher nickel materials have the same energy density as lithium cobalt oxide, then it will cut the cost and cut the need for cobalt. But then any electronic gadget, your watch, your phone, your laptop, computer, it's energy density per unit volume that matters more than anything else. So things like lithium sulfur will not work in volume controlled environments. It will have an exceptional energy density on a weight basis if we can solve the technical problem.
Thank you.
Yes.
Do you have any predictions for the future in terms of energy storage? What do you think will happen in 5 to 10 years? What are we going to use in our everyday life? Is it going to change drastically, or are we going to stay with more or less the same technology we're using today? It's just more stabilized, more suitable for
So it's my feeling that we have a large found energy consortium try to raise the energy density to 500 watt hours per kilogram from today's 250, which will cut the rate and the volume, so that will make them much better for a number of applications. So I think that's going to happen. And was there another bit of your question I missed?
So is there going to be a different technology, is there something new that's emerging that we are going to use in 5 years, or is that unlikely?
We invented the lithium-ion battery in 1972, 73. It took until 91
Right.
for it to become commercially successful. A number of companies, including Molly Energy, went commercial earlier, but they lost money. So it takes a long time for any new technology to get ready to be marketed in a safe